Good morning. We will start session 4 on chapter areas of parallelogram and triangle. So we'll resume with the exercise what we started yesterday, and there are quite a number of sums in this exercise. In today's session, we completed till 5th one. We will start from the 6th one today. We will not go with the same numbers what are given. We will just pick out few simple sums in today's session and leave not the complicated one. I can say the sums which are quite lengthy. We'll push them to the tomorrow's session. So please see the number which I put across the question here. 6th one. Diagonals AC and BD of a quadrilateral ABCD intersect at O. So a quadrilateral is given A, B, C and D, and the diagonals intersect at O. Right? So given the same thing, we will write in quadrilateral ABCD, diagonals AC and BD intersect. They don't bisect, intersect at O. Apart from this, such that though they intersect, also it is given OB is equal to OD. OB is equal to OD. This much is given. If AB is also equal to CD, AB is also equal to CD. One side is equal and its opposite side is equal. What we have to prove? So three things we have to prove here. Triangle DOC is area of triangle DOC is equal to area of triangle AOB. Area of triangle DCB is equal to area of triangle ACB. And we have to prove that ABCD is a parallelogram. I will not try to prove three things are there here. To do this, we require a construction. They have already given in the hint, but in examination, hint will not be provided. From B and D, draw perpendiculars to AC. That means I can draw a perpendicular here, say E, and a perpendicular here, F. Okay. So these are the perpendiculars drawn. So first of all, we have to, our aim is to, not proving areas, our aim is to prove that it is a parallelogram. So construction we will write, draw DE perpendicular to AC and BF perpendicular to AC. Same thing only here. Since they are perpendiculars, that means the height is equal. Proof. We will choose two triangles and prove that they are congruent. Which two triangles? These two triangles we will prove that they are congruent. So in triangle DCE and triangle BAF. So first of all, I know that here CD is equal to AB. Reason given. Then this is 90, this also is 90. Angle DEC is equal to angle BFA is equal to 90 by construction. A 90 degree, then what is this? This became hypotenuse. I want one more side. Can I tell here DE is equal to BF? Because what you can tell here is DE is equal to BF. It's only because it is from the same, what you can say is the the perpendiculars drawn from to the same diagonal. That is why the height is same, what you can say here. Heights are equal or given, I will just write here. By construction I will write. By construction. Okay. So from this I can tell that triangle angle DCE is equal and congruent to triangle BAF by RHS congruence rule. Okay, so they are equal and congruent because we have an hypotenuse, then we have a side, and we have a 90 degree. From this, can I tell that this angle is equal to this angle CPCD? Angle DCE is equal to angle BAF CPCD. But what are these? But these are pair of alternate angles. Okay, but these are pair of alternate angles. In alternate angles are equal, lines are parallel. Therefore, CD parallel to AB. In a quadrilateral, if a pair of side is equal and parallel, then it is a parallelogram. So this was already equal, which is given. So therefore we can say that it is a parallelogram. Now see here, though I have written here children, DE is equal to BF, that is DE is equal to BF by construction I have written. Suppose if I choose these two triangles, okay, and tell that this angle is equal to this angle. See here, because it will become much lengthier if I write it. Vertically opposite angle, 90 degree. This side is equal to this side. It is already given. That means this triangle is equal and congruent to this. From CPCD, I can tell that this side is equal to this side. I can do that. So from construction I have written. What construction we have drawn here, we can prove that from the CPCD that those two sides are equal. From construction, if it is written, it is understood. CD parallel to AB, right? Therefore, in a quadrilateral, you know the statement what you write. If a pair of sides is equal and parallel, then it is a parallelogram. That statement you have to write. Therefore, ABCD, CD parallel to AB, that is what we have to prove, and we proved it here. Okay, or we had to prove that DA parallel to CB we had to prove. DA parallel to CB we had to prove. It is automatically understood. ABCD is a parallelogram and DA is parallel to BC. We proved actually the third part here directly. Now is this very clear? Okay. Now let's concentrate on the next part what we have to prove. So I will just erase this. Let us see next what have they asked us to prove it. They have asked triangle DOC. Triangle DOC is area of triangle DOC is equal to area of triangle AOB. What we have to prove, that is this. So we know that it is we had proved that in the earlier part also. Since it is a parallelogram, it divides the triangle into congruent part also we can use. Since we have height here, let us use the height. Area of triangle DOC is equal to, actually there are many methods to for this particular sum. You can even use median property also to prove, and you can get it done very easily. DOC is equal to half into base into height. So DOC is what? Half. What is base for DOC? Can I tell OC is the base? What is height? DE. Equation 1. Next, area of triangle, what we have to find? AOB is equal to half into base into height. Half. What is base here? OA. What is height here? BF. I will write here half instead of OA, because OA is equal to OC. In a parallelogram, diagonals bisect each other. I will use OC only. Instead of BF, BF is equal to DE. I use DE only here also. Equation 2, reason OC is equal to OA and DE is equal to BF. From 1 and 2, area of triangle AOB is equal to area of triangle DOC. Axiom 1. Hence proved. Right? This part we proved it. Now only left is DCB area and ACB area. I'll again erase this now. Let's check the last part, how to prove it. Okay. Now what we have to prove? Area of DCB, DCB and area of ACB. That means to these two, if I add this part, will I get it? Yes. And right now, area of triangle DOC is equal to area of triangle AOB. Proved above. You have just proved it. To this, I am going to add this part. Area of triangle DOC plus triangle BOC plus area of triangle only we can say, or triangle, anything is same children. Area of triangle AOB plus triangle BOC. What it is? Axiom 2. Equals are added to equals. DOC plus BOC. DOC plus BOC is nothing but area of triangle DCB. We got it. Area of triangle DCB. AOB plus DCB is nothing but area of triangle AC. When equals are added to equals, the wholes are equal. Very clear? Okay. Seventh one is also very simple. Along with sixth, we will prove seventh one also. I will be going a bit slow in this chapter because it's easy, but you need to know so many different concepts here. Seventh one, D and E are the points on the side AB and AC of triangle ABC. So first of all, we will draw on sides AB and AC. So D and E. So if this is D, this has to be E. D and E are the points on the sides AB and AC of triangle ABC such that area of triangle DBC, I have to join, is equal to area of triangle ABC. Prove that DE is parallel to BC. It is nothing but from converse we can tell that they are equal. Let's first write given in triangle ABC, D and E are the points on AB and AC respectively. Apart from that, what is given? Area of triangle DBC is equal to area of triangle ABC is given. What we have to prove? We have to prove that DE is parallel to BC. Proof. I will write same thing. Area of triangle DBC is equal to area of triangle EBC. Check where is DBC. DBC is equal to EBC. That means they are standing on the same base. These triangles are standing on the equal areas. Therefore, by converse, they are standing between same parallels. This implies, if I have discussed this, if the areas of the triangle are equal and they are standing on the same base, that means they stand between the same parallels. DE parallel to BC. Hence proved. A very simple one. Yeah, make a note children. What I have done is 6th one I have done, 7th one I have done. 8th and 9th we will push to the tomorrow's session. We will finish today 10th and 11th one, right? Simple ones as I have told you. The linear ones will push to the tomorrow's session. So say 6th and 7th we are done. Next we will move on to 10th and 11th one because they are very simple. It's the same concept we are repeating again and again. Let's finish such sums. Please mark the question numbers and write the question numbers accordingly. However I am teaching, write it accordingly with those questions only. Okay. So the next one, 10th one, diagonals AC and BD of a trapezium ABCD. So if this is a trapezium, ABCD is a trapezium. Diagonals AC and BD of a trapezium with AB parallel to CD intersect each other at O. Let's write question number 10. Given in trapezium ABCD, AB is parallel to CD, AC and BD intersect at O. To prove, area of triangle AOD is equal to area of triangle BOC. Area of triangle AOD is equal to area of triangle BOC. What we have to prove it here. Proof. Now, can you see any two triangles if they are standing on the same base and between same parallels here? Yes. I can tell directly now. Area of triangle ABD is equal to area of triangle ABC. Reason I will write here. Triangles are standing on same base. What is the base? AB. Base always I have told you have to be mentioned. And between same parallels AB parallel to CD, right? So equation 1 I will write it. Anything. These two areas are equal. What I will do from both this triangle, I will subtract this triangle. AOB triangle I will subtract. If I subtract from this whole AOB, what will I get? AOD. And here I will get BOC. That's all. Need not write equation 1, that's okay. Area of triangle ABD minus triangle AOB is equal to area of triangle ABC minus triangle AOB means understood as area only minus triangle AOB. Axiom 3. Equals are removed or subtracted from equals, the remainders are equal. ABD minus AOB is what? Area of triangle AOD is equal to area of triangle BOC. Hence proved. That's what they had asked you. Quite a simple one. That's what all are similar ones. I'm trying to prove it one after the other. Next we'll go with the 11th one. In the figure, ABCDE is a pentagon. A line through B parallel to AC meets DC produced at F. Show that. So let us first draw accordingly what they have given. So this is D, C, F. This is A and B. And here it is E and A. Okay. So given A, B, C, D, E. Where is this? A, B, C, D, E. Okay, this is a pentagon here. A, B, C, D, E is a pentagon. I'll just highlight those points. A, B, C, D, E. What is a pentagon? It's a five-sided figure, five-sided polygon. Is a pentagon. You've studied this in standard 8th. So a line through B parallel to AC. A line through B parallel to AC. That means a line which is drawn through B, which is parallel to AC, meets DC produced at F. A line through B which is parallel to AC. So where is the B? This line is parallel to AC. A line through B is parallel to AC meets DC produced at F. Those two are the parallel lines. So we will write directly in the given AC parallel to BF. Okay. Not required it is produced to BF or whatever. What we have to prove? To show or to prove that area of triangle ACB is equal to area of triangle ACF. This is the first one. Second one, you have to prove area of, it's a quadrilateral, not a par, we don't know what it is. AEDF is equal to area of ABCD. Area of a quadrilateral is equal to area of a pentagon we have to prove. First one we'll start with. I think first one is the direct one. Where is ACB? ACB and ACF. Are they standing on the same base? Yes, in AC and between same parallels AC and BF. Directly I will tell here. Area of triangle ACB is equal to area of triangle ACF. ACB. Double line I have just drawn and ACF. Right? Very clear now? So I will write here triangles are standing on the same base. Please write the complete reason AC and between same parallels AC parallel to BF. I have written only half part. You are supposed to complete that full. Then now since this is there, for both the parts what I will do here is for ACB. ACB is here, ACB is here. I will add this quadrilateral AEDC. So what will I get? Let us see. Area AEDF, we have got it. 1 second children. AED. Okay. Area of triangle ACB plus I will write AEDC is equal to area of triangle ACF plus AEDC. AEDC. Now see, let us see completely. Where is ACB here? ACB is here. For this, if I add AEDC, what will I get? I will get the point as AEDC. Where is E point? Okay. AEDCB. Will I get this? First write down that whatever you get. ACB is here. This is ACB. Okay. For this ACB, if I am adding this, I will get this whole portion, right, as you read it. How do you read it? You read this as area of AEDCB. Keep this as it is equal to, read this part, area of ACF. Where is ACF? This is ACF. For this, if I add this, what do I get? AED. CF is one single line, so I can read this as AEDF directly, because this is a straight line, children. There is no curve or point. It is one straight line. Okay. If I have a quadrilateral, say ABCD, and if I add one more point here, E, I will not read this as AEBCD, right? So E is a point. Similarly, C is a point. So I am just neglecting this point and I am reading this. Is this the same thing? AEDF, ABCDE. Now I have got AECDB. How they have written? Write it in that manner. ABCDE. Read it in that manner. ABCDE is equal to area of AEDF. Very clear? It's a very simple one. Only thing we have to identify what? Very simple question. Add this quadrilateral to the areas equal. I need to write a reason here. So first one is anyways proved. Second one is axiom 2. Equals are added to equals. The wholes are equal. So with this we complete today's session. I have made today's session very simple with very similar type of sums. See, the things becomes very easy when we solve similar type of sums. Then the next part we have one similar ones only, but a bit different type, which is quite lengthier. We'll keep that for the next session.